everyone, I'm Won-Lee. We have studied basic material of regression analysis. Now we have to know ANOVA table in regression analysis and determination coefficient. It is a very important concept here. All right, let's see how to get the analysis of various table. Okay, in regression analysis, ANOVA table is also obtained. This means the ANOVA table computed by computer is used to interpret the result of regression analysis. What does the ANOVA table consist of? You know that ANOVA table. Source, sum of square, degrees of freedom, and the mean square, F value, and P value. This is ingredient of ANOVA table. Let's examine how to get the sum of squares in regression analysis. Let's see yi minus y bar. Yi minus y bar can be divided into two parts. Yi minus y bar is yi minus yi hat plus yi hat minus y bar. The two parts. This one plus this one. Cancel out, so equality holds. Now, if we square both sides and sum them up, we have the following equation. Summation yi minus y bar square is summation yi minus y bar square plus summation yi hat minus y bar square. Okay, and 2 plus summation cross product term will be 0. No doubt. So what is this one? Total sum of square. That is, this deviation sum of square of sum of deviation squared is total sum of square, right? Plus this one is what? What is this term? Residual, right? I showed you this way, then here x, okay, this value is y hat, this one is y, okay, y minus y hat is residual. And what is this part? yi hat minus y bar. There are many y's, so let's see, y bar here, sample mean of y's. Then y bar here, then yi hat minus y bar, this part, say what? Slope. So we call this part is regression sum of square, this one. I will show you later this part precisely. The relation of degrees of freedom is as follows. What is the degrees of freedom here? N minus 1. What is this? N minus 2. We have seen the degrees of freedom of SSE. Here, this one, yeah, there are two estimate. How many sum? N. So how many estimated parameter? 2. So N minus 2 is degrees of freedom of SSE. And what is this? You don't have to think about that deeply. For equality, just one. Actually, this is a number of explanatory variable. We are talking about the simple linear regression model. So number of explanatory variable is 1. So relation of degrees of freedom like this. This sum of square and the degrees of freedom. Then we can consist of ANOVA table. Regression. This one, regression. And residual, this part, residual, and the total. SSR, the real value, calculated value of SSR will be show up here. SSE, SST. Degrees of freedom 1, n minus 2, n minus 1. Mean squares, SSR divided by degrees of freedom. Okay? SSE, MSE, MSR is just in this case same as SSR. MSE is SSE divided by its degrees of freedom. I said this part is important. And the F value is SSR, mean SR divided by MSE. The value will be calculated here, and the P value. Okay, the sum of squares is also referred to as variation. It is a terminology. Specifically, total variation, SST, this one is sum of square. Sometimes we call variation, total variation. SST equal unexplained variation, SSE. This part is SSE plus explained variation, SSR. So residual sum of square, what is a residual? Residual is realized value of error. Can you explain error? We cannot explain error. So residual. So this part is unexplained variation. And this one, regression sum of square, is explained variation. Okay, terminology. The residuals are the observed value of error. Therefore, it is the part that is not explained. We cannot explain error, residual. The regression sum of square is sum of squares of parts explained by the regression line. What? Slope. I said this part is a slope. This part implies slope. Thus, it is referred to as explained variation. The coefficient of determination indicates how much the explanatory variable x accounts for the variability in y. Can understand that? Determination coefficient expressed as percentage. So okay, SSR divided by SST is what? Determination coefficient, and denoted by R square. It tells us what percentage of the father's height X explains the son's height Y. What percentage father's height X explains the son's height Y. Therefore, the coefficient of determination is defined as follows: R square equal to SSR divided by SST. The coefficient of determination plays an important role in regression analysis. When you study regression analysis more and more, then R square is very, very important thing, important concept in regression analysis. So briefly, I told you the structure of ANOVA in regression analysis, how to get SST, SSE, SSR here, and I introduce coefficient of determination today. I'm gonna explain a little more about the determination coefficient next time because it is very important to catch the concept. Okay, thank you. Bye.